If you search for 3I/ATLAS tonight, you'll find two parallel worlds of conversation. In one, scientists talk in units and vectors, plotting arcs through the solar plane, arguing about orbital elements and outgassing behavior. In the other world, the louder one, 3I/ATLAS, is already legend. It's been called a messenger, a fragment of something ancient, a probe from another intelligence, and even part of a fleet moving deliberately through our neighborhood of space. Two worlds, same data. One sees a comet, the other a signal. And the truth, whatever it is, sits somewhere between those worlds, waiting for us to notice. The alien probe idea didn't start with Atlas. It began with the first interstellar object we ever found, Oumuamua. That long, slender, tumbling object that slipped past Earth in 2017, moving faster than anything we'd ever tracked before. It reflected light unevenly. It accelerated without a visible tail, and it sparked one of the strangest scientific debates in decades. Some called it an interstellar rock, others a frozen shard of nitrogen ice, a fragment from a world long dead. But one voice said what many were quietly wondering. What if it wasn't natural at all? That voice belonged to Harvard astrophysicist Avi Loeb, who suggested it could have been a fragment of alien technology. A light sail, pushed by starlight, drifting across the galaxy. Most of his colleagues disagreed, but that single sentence, printed in a major scientific journal, did something rare. It cracked open the boundary between astronomy and imagination. For years, every strange light, every unexplained motion, was quietly folded into that idea. And so, when another interstellar traveler appeared, people were ready for it to mean something more. Atlas, discovered by a sky survey on the slopes of Mauna Loa, was brighter, more volatile, and far more dramatic than Oumuamua. And that made it a perfect canvas for speculation. You could watch in real time as observatories uploaded data points, brightness curves, coma expansion, tail length, and within minutes, entire online communities spun those numbers into a story. To them, ATLAS wasn't disintegrating, it was activating. The jets of gas streaming from its surface weren't outgassing, they were propulsion. The fragments breaking away weren't signs of decay, they were deployments. They zoomed in on the photos, low resolution, pixelated frames of faint smears against a field of stars, and saw shapes, lights, patterns. To some, it looked mechanical, to others, almost alive. And then came the fleet idea. It started, as these things often do, with a coincidence. A handful of small objects on similar trajectories, each faint, each distant, each briefly crossing the same patch of sky. To astronomers, that's common. Space is crowded. Survey telescopes pick up a dozen unrelated objects in a single image all the time. But to a certain kind of eye, it looked deliberate, like formation flying, like escorts, like something moving with intent. Maps began circulating online, showing converging orbits and shared approach angles. Threads appeared, connecting unrelated discoveries under one idea. That 3I/ATLAS was the lead ship of a convoy entering the inner solar system. Of course, the data doesn't support that. Each of those dots moves on its own curve, each obeying the same predictable physics that rules everything else in space. But it's also true that our instruments don't see everything. They catch moments, flashes, trails, a few points of light across a sea of darkness. And between those points, our imaginations fill the void. Because the question, what if it's real, is powerful, It's older than astronomy itself. We've been projecting meaning into the sky since we learned to look up. Sometimes that instinct leads us astray. Sometimes it leads us toward discovery. Maybe that's why these stories catch fire so fast. They speak to something ancient in us. The feeling that we're being watched, or maybe remembered. That we aren't just looking at a rock passing through sunlight, but at a message older than our species. Most scientists will tell you that ATLAS is just a comet, a volatile ball of ice and dust shedding material as it warms. That's probably true. But it's also true that comets are messengers in their own right. Every one of them carries the chemistry of another place, frozen history from the time before our sun existed. So maybe, when we look at 3I/ATLAS tonight, we're not seeing a machine or a fleet. But we are seeing a visitor from another star, a fragment of another world, traveling through ours for the first and last time. And that alone should make us pay attention. For all the stories that swirl around it, 3I/ATLAS began as a handful of pixels. Discovered by the Atlas Sky Survey in early 2024, it first appeared as a dim point of light, an unnoticed speck in the deep background of the night sky. Then came the follow-up observations, the cross-checks, and the quiet realization that this object wasn't following any of the usual rules. Most comets trace long ellipses, looping around the sun like runners on a track. Atlas didn't. Its path was open-ended, a hyperbolic trajectory, the unmistakable signature of something not bound to our star at all. That single clue changed everything. It meant this object came from somewhere else. Not the outer reaches of our solar system, not the Oort cloud, but from interstellar space. The gulf between stars, where distances are measured in light years and time itself feels slow. It's one thing to imagine such a journey. It's another to see the faint light of something that's actually made it here. Astronomers around the world turned their instruments toward it. Spectrographs measured its composition. Photometric models tracked its spin and brightness. And gradually, the shape of the mystery began to sharpen. They found cyanide gas, carbon monoxide, and dust made of silicates, the same ingredients that form the icy cores of comets in our own solar system. No metal alloys, no radio signals, no anomalies that hinted at machinery, just ice and rock, but ice and rock from another sun, its rotation irregular, its brightness variable. It flared as it neared the sun, sprouting a faint tail that streamed behind it for millions of kilometers. A sure sign that sunlight was boiling material off its surface. So far, nothing alien, nothing artificial. Just the ancient chemistry of another system, reacting to the warmth of ours. But even that's extraordinary when you think about it. This object, a chunk of frozen dust drifting through emptiness for millions of years, crossed the invisible borders between stars and stumbled into our field of vision for only a moment. And in that instant, we saw a piece of another world. We talk about comets as if they're familiar, but interstellar ones are not. They're strangers. Each carries a fingerprint of the place it came from. The mix of elements, the isotopic ratios, the history written in their ices. They're like messages in bottles from the early universe. When scientists looked closer, they found that ATLAS's chemical makeup was subtly different from anything native to our sun's nursery. Its ratio of volatile gases didn't match the ones we see in local comets. That means it formed under different conditions, a different temperature, a different star, a different history. That realization, quietly confirmed in observatories around the world, means that right now, in our sky, there's a fragment of alien geology visible to our telescopes. Not a ship, not a probe, but something far rarer, an authentic piece of another solar system, passing close enough to study before it vanishes forever. Even so, the debate doesn't end there. Because every time data brings us closer to certainty, someone finds a new way to question it. A flicker in a light curve, a deviation in the orbital fit, a fragment that seems to move against the model. Each small inconsistency becomes fuel for another idea, and that's where things start to blur again, where observation and interpretation collide, and the human imagination slips back into the story. Because while the numbers may say one thing, our minds are wired for something else entirely, to look into the unknown and find meaning. Even with the most powerful telescopes, the most precise instruments, there are limits. Space is vast, light is dim. Every observation is just a snapshot in time, a fleeting signal from an object that has been traveling for millions of years. Atlas is tiny in cosmic terms, a few kilometers across, a speck of ice and rock, and yet it has become the focus of thousands of eyes, both human and mechanical. Every flicker in its brightness, every subtle change in its trajectory is scrutinized, measured, cataloged. And yet, each measurement has uncertainty. Each number leaves room for doubt. Some of these anomalies are simple: shadows, instrumental noise, statistical fluctuations. Some are intriguing: slight deviations in orbit, unexpected jets of gas, an irregular rotation that seems almost intentional. We can measure them. We can describe them in spreadsheets and graphs. But we can't know the why. Not yet. And that's where imagination steps in. Humans are wired to see patterns, even where none exist. We connect dots across empty space, seeking meaning in randomness. We see a brightening here, a fragment there, and our minds ask, is it coincidence, or is there intent behind it? Some online communities, fueled by curiosity and a bit of obsession, have created elaborate maps of ATLAS's path. They track fragments, arcs, angles. They overlay the orbits of distant stars and speculate on cosmic alignments. To the outside eye, it can look like overreach. But there's a deeper truth here. When we face something unknown, we instinctively build stories to hold it. Even scientists, trained to distrust patterns that don't exist, occasionally pause. Oumuamua taught them caution and fascination. Borisov reminded them of probability and statistical expectation. Atlas now reminds them, again, how little we actually know. And this is the tension at the heart of interstellar visitors. The precise mathematics of orbital mechanics exists side by side with the boundless possibilities of imagination. We can describe trajectories with decimal points, predict brightness curves, measure chemical signatures, but we can't capture intention, history, or context beyond the numbers. In that space between certainty and wonder, stories flourish. The probe hypothesis, the fleet theory, the idea that these objects are sending messages across the void. They are, at first glance, absurd, and yet they are also compelling, because they tap into something ancient in us, the desire to know, to witness, to feel connected to the vast, indifferent cosmos. And perhaps that is why fascination spreads so quickly. The data may say one thing, but our minds crave more. We read meaning into light curves. We see signals in static. We interpret shadows in the tail of a comet as intent. Atlas is a mirror of what we know and what we long to know. It reflects our precision and our imagination, our curiosity and our fear of insignificance. For a few hours tonight, it's within reach. It won't stay long, and the universe doesn't pause for our questions. So we measure what we can. We speculate where we must, and in that delicate balance between what science allows and what wonder demands, the story of ATLAS unfolds. Here, the debate isn't just about ice and rock. It's about perspective. It's about how we encounter the unknown, how we make sense of fleeting moments, and how we face the possibility that the universe is far stranger than our instruments alone can reveal. Even with certainty in our numbers, uncertainty lingers. Even with clear spectra and orbital fits, mystery remains. And it is in that lingering space between evidence and imagination that ATLAS becomes more than a comet. It becomes a question: what might be possible? And in asking that question, we begin to understand why this tiny visitor has captured the attention of so many across the globe tonight. When a mystery refuses to resolve, people start building ladders to reach the answers themselves. And with Atlas, those ladders have climbed high. Every few weeks, new theories surface, intricate, imaginative, sometimes breathtaking in scope. Each one starts with a kernel of truth, a small piece of data, and grows into something far larger than the science alone can explain. One of the most popular claims is that Atlas isn't a lone traveler at all, but part of a coordinated arrival, the third piece of something much bigger. Oumuamua was the scout, Borisov the observer, ATLAS the messenger. 3 interstellar objects, 3 distinct trajectories discovered within a single decade, after billions of years without any. To some, that timing feels too precise to be chance. They point to patterns, each object arriving closer in time, each with unusual characteristics, each defying expectations in small but significant ways. Maybe, they suggest, these aren't coincidences. Maybe they're breadcrumbs, signals spaced across years, guiding our attention to a larger message. The triad theory, as it's been called, suggests that these objects are connected, a slow-motion sequence unfolding across decades, orchestrated on a cosmic scale. To skeptics, that's nothing but human pattern-making. To believers, it's the first whisper of something deliberate moving through our sky. Then there's the energy theory, the claim that ATLAS flared with unnatural brightness as it neared the sun, as if harvesting energy. Images show a rise in luminosity far greater than expected. To scientists, that's easy to explain. Volatile ices venting gas as sunlight warms the surface. But online, another interpretation caught fire, that the flare wasn't natural at all, that it was an activation. Some even argue that the object's fragments aren't random debris, but detachable units, smaller craft-breaking formation as Atlas neared its perihelion. One theory describes it as a seed ship, a self-replicating machine, shedding parts as it travels, dispersing across systems to gather information. Others go further still. They see the arrival of ATLAS not as random chance, but as a signpost, part of a recurring cycle. A pattern stretching back through history when bright comets appeared before turning points in civilization. In ancient records, comets were omens, heralds of change, both good and catastrophic. Now some believe we're seeing that archetype play out again, written not in myth, but in data. Even the name ATLAS feeds the speculation. A name chosen by the automated system that discovered it, but one that feels almost too poetic. The Titan who carried the heavens, the guardian of celestial maps, the one who held the weight of the cosmos on his shoulders. Coincidence? Maybe. But in stories like this, coincidences rarely stay. Coincidences for long. In the deeper corners of the internet, you'll find the network theory. It proposes that interstellar space isn't empty at all, but a web, a silent network of ancient probes drifting between stars, passing information back and forth over eons. To them, 3I/ATLAS is just one node, part of a system older than humanity, possibly older than our sun. Each visitor we detect is a ping in that network, a momentary handshake between civilizations. None of these claims have proof, but they all share one thing in common. They speak to a hunger for meaning, for connection, for the idea that we are not just observers of the universe, but participants in a much larger story. Even scientists, the ones who roll their eyes at the probe talk, feel a version of that same pull. Because no matter how rational we are, there's something irresistible about the thought that we might not be alone, that something out there could have noticed us long before we learned how to notice it. And maybe that's why 3I/ATLAS resonates so deeply right now. Because in an age of data and algorithms, this little speck of light reminds us that there are still mysteries big enough to humble us. It's the unknown, moving visibly across our sky. And it asks, without words, the oldest question we have ever asked. What if, for all the noise, the theories, the digital storms of speculation, the real work continues quietly? In observatories scattered across mountaintops and deserts where the night is still and the data speaks in numbers instead of headlines. Here, scientists trace ATLAS not with imagination, but with light. Every photon that reaches an instrument is a piece of its story. The color of that light reveals temperature, motion, and the fingerprints of the elements locked inside. From Hawaii to Chile to the Canary Islands, telescopes have captured its fading trail. Spectrographs dissected the glow, teasing out cyanogen, carbon monoxide, ammonia, silicate dust. The same ancient ingredients found in comets born near other suns. Each spectrum confirms what most astronomers quietly expected. Atlas behaves like a natural object, a volatile wanderer, warming, venting, spinning apart under the relentless pressure of sunlight. The doesn't make it ordinary. Interstellar comets are anything but. Only 3 have ever been seen. Each one is a message written in chemistry, a sample from a distant stellar nursery. They tell us how other systems formed, how planets might have evolved elsewhere, and by comparing their ingredients to our own, we learn what's universal and what's unique to home. In the raw data, there are no hidden signals, no radio pulses, no repeating modulations. Just the quiet hiss of background noise, the static heartbeat of space itself. But even silence can teach us things. It tells us how sensitive our instruments have become. Able to hear a whisper across billions of kilometers, to measure a molecule evaporating from a fragment of ice older than our species. And yet, for all our precision, a simple truth remains. We only catch glimpses. A few weeks of observation, then the object is gone forever. We're reconstructing a cosmic life story from a handful of pages torn out and carried on the wind. That's why every anomaly feels precious. Every uncertainty is a doorway to possibility. When data doesn't fit perfectly, we don't just discard it, we lean closer. Sometimes a flaw in the pattern leads to discovery. Sometimes it leads to illusion. Science lives in that distinction. In the case of ATLAS, the numbers point firmly toward the natural, a visitor shaped by physics, not intention. But even in confirming that, we're reminded of something larger. Because the fact that we can track it at all, that a fragment from another star can drift for millions of years and end up reflected in our telescopes, is itself extraordinary. It means the universe is not separate from us. It flows through us, occasionally sending these quiet ambassadors across the void, each one a clue to our shared cosmic ancestry. Each one proof that matter, like memory, travels. So yes, the data brings us back to Earth, but not in disappointment. It brings us home to wonder, grounded in evidence yet open to the infinite. Because the line between discovery and mystery is thin, and sometimes in chasing one, we find both. When the numbers fade and the telescopes turn to other targets, Atlas keeps moving. Silently, relentlessly, back into the dark between stars. No one will ever see it again. It will drift for millions of years through that cold expanse, a fragment of memory carrying traces of sunlight that once touched our world. But for this brief intersection, these few nights when it crossed our sky, we were part of its story. For once, we weren't just watching the universe from the safety of our small orbit. We were in dialogue with it. A speck of humanity noticing another speck, both suspended in the same cosmic sea. That's what makes objects like this so powerful. They remind us how thin the line is between out there and here, how easily the distant becomes intimate, how the light from something born under another sun can fall across our planet and be caught in a lens, decoded, discussed, and wondered over by minds made of stardust. When people ask whether ATLAS is alien, the truth might be simpler and stranger. Everything beyond Earth is alien. Every atom that didn't originate here tells us that the universe shares itself freely, that we are built from the same scattered ingredients as the things we chase across the sky. So maybe the point isn't whether ATLAS is a machine or a comet. Maybe it's that we noticed it at all. That for a fleeting moment, billions of years of distance collapsed into a shared awareness. Every generation gets its visitor. A brief reminder that the cosmos is still moving, still creating, still full of questions that refuse to end. And when the next one comes, we'll do what we always do. We'll measure, we'll speculate, and we'll look up. Knowing that even if we never find a definitive answer, the search itself is what connects us to the stars. Because wonder is not the opposite of knowledge. It's the beginning of it. So tonight, as Atlas fades back into the void, maybe that's what it leaves behind. Not a message from another civilization, but a mirror held up to our own curiosity. A quiet reminder that the universe doesn't need to speak for us to listen. Sometimes its silence is the message. So here we are, the night of closest approach. Above the quiet hum of cities, past the thin breath of the atmosphere, somewhere between Mars and Mercury, a visitor from another star is passing through sunlight. For most of us, it's invisible. A faint, anonymous blur in a telescope feed. No headline could make it brighter. No theory could make it linger longer. By tomorrow, it will already be moving away, its light dimming, its trajectory opening back into the black. And yet tonight, for a few fleeting hours, it is here, a grain of another world, drifting through ours. A whisper across the endless dark. Proof that the distance between stars isn't silence, it's only space. People will argue about what it means. They'll debate theories, plot graphs, search for patterns, and maybe, just maybe, see themselves in the mystery. Because when we watch something like ATLAS, we aren't just studying a comet. We're looking at a reflection of our own curiosity, our own need to find meaning in motion. Perhaps it's just ice and rock. Perhaps it's something more. The truth doesn't change what it stirs in us. That quiet sense that the universe is still alive, still sending messages in the form of questions. And maybe that's the real story of this night. Not that an interstellar visitor has returned, but that we were here to see it. So, as it slips back into the dark, remember this. Somewhere between the stars, another traveler may already be on its way. The sky will look empty tomorrow. But tonight, the universe feels close.